This part is going to discuss the liver. The liver is that huge organ that is found in the upper right quadrant of the abdomen. The liver makes a lot of exocrine secretions and mainly bile, and it will release it into the duodenum. That bile is secreted by hepatocytes, which are the liver cells, not by the gallbladder. The gallbladder can store and concentrate bile. It will remove some of the excess water, but again, gallbladder does not make bile. Bile contains bicarbonate ions. It has cholesterol, phospholipid, bile, some organic waste products that the body doesn't need, and we want to kind of excrete it through our feces, and a group of the most important part of bile, and those are bile salts. And here again, hopefully this is a familiar image to you folks. You can see here again bile that is being made by the two lobes of the liver, the right and the left lobe. Actually, the liver has 4 lobes, but we're just seeing the 2 bigger lobes here. And then the bile will go into their hepatic duct, so the right and the left hepatic duct into your common hepatic duct. If it'll be stored into the gallbladder, it would do so, but when it's time for it to be released, it'll go down through that little tiny short cystic duct. That cystic duct combines with the common hepatic to make a common bile duct, and the common bile duct goes all the way down in order to open and release its contents into the duodenum. It has a common opening with the major pancreatic duct, and it is controlled with a sphincter known as the sphincter of Oddi that we said, we mentioned it, that CCK, or cholecystokinin, contracts the gallbladder to release bile while it relaxes the sphincter of Oddi. Okay, so let us take a look at what is known as the enterohepatic circulation of bile salts. So again, you can see those bile salts that are being made going through that common bile duct into the small intestine, into the duodenum. Well, the majority of bile salts will actually be reabsorbed from the small intestine and go back through the hepatic portal vein back to the liver. We only lose about 5% of bile salts would be lost in feces, and which is not a big deal. The liver has the ability to synthesize those 5%. So it is that recycling of bile salts that occurs that is known as the enterohepatic circulation of bile salts. So again, bile is mainly needed actually during a fatty meal. Okay, so and most of the bile salts enter the intestinal tract with the bile and become reabsorbed. But again, we only lose about 5% of it, which that escapes that recycling and it'll be lost in the feces, but the liver again can synthesize that new bile salt from cholesterol in order to replace the 5% that was lost. And the bile salts will be reabsorbed or be absorbed from the small intestine with a transporter known as a sodium coupled transporter. And that happens in the ileum, which happens to be also known as the terminal ileum, or the last part of the small intestine. Okay. During the digestion of a meal, you'll find that there is recycling of bile salts that happens several times via that enterohepatic circulation. We also want to introduce the hepatic portal system, which is the plainly where everything that is absorbed from the small intestine, all of the venous circulation from the different parts of the digestive system, the stomach, the small intestine, and the large intestine, all of that venous circulation does not go back directly into the inferior vena cava. It goes through the liver first. So that hepatic portal circulation delivers all of the venous blood from the different parts of the digestive system into the liver. And in the liver, a lot of things are going to happen. Okay, so that the liver will get all of the nutrients from the small intestine that were just absorbed. It will also get through that hepatic portal system. It'll receive insulin and glucagon from the pancreas. And anything that was absorbed from the small intestine, if we ingested anything that is harmful, the liver can detoxify it. And that includes actually some of the medications and drugs that we use. And that is why if anybody has some form of liver failure, they would have to decrease their doses because they've lost that detoxification advantage of the liver. And that ends the liver part.